pray to the demo gods properly. I think we've done a bit of that already.
Yeah.
We'd really missed in-person conferences, so much so that we had to buy our own T-shirts as well. So we're really glad to be here in MS Build in person with you guys, and to all the people online as well. Really good to be presenting to you. In terms of introduction, my name is Taran. I am a Microsoft MVP in DevOps. I also run engineering services for Avanade across UK and Ireland. I've got my colleague here.
Yeah, hi there. First of all, I'd like to thank you for everyone for coming, and it's nice to have an in-person build event. My name is Marcel Lupo. I'm also working at Avanade UK and I'm DevOps manager there, and also a MVP in Azure DevTools. So what we're going to show you today, or talk to you about today, is about how we can use serverless logic with Azure functions in Azure, and having decoupled serverless compute and having dynamicity and adding real value in app modernization and in using Azure functions, basically.
That's the plan. All right. So moving on, how many people are old enough to remember IIS? Plenty of hands, right? So I'm not alone. You're not alone. It was a bit of a love and hate relationship with IIS. It was brilliant. It worked, but it got really difficult really quickly. And then you had new versions of IIS when Windows came out, and then you had to like adapt breaking changes, get things to work again. And if your enterprise app was anything web related, you'd be in IIS. But also, if the app was starting to scale, you'd go from being in one box to another box to another box. And scaling was a bit of a challenge because after you'd scaled, you still need to patch every server. You needed to manage the config, and it was a bit of a nightmare, right? And as much as I enjoy being an ops person, I don't think life of an infrastructure ops engineer with IIS was that easy. Marcel, do you have any recollections of those days?
Yeah, so those were the days. I mean, managing servers, patching them, keeping them alive, having to make the changes across so many different boxes in a data center. I mean, it was just a whole task in its own just to keep these things running. So with the modern cloud and advances in cloud, how can we address this sort of in today's issues? Like, how can we address some of these scalability issues and manageability?
Sure. So as a developer, I don't really care so much about the infrastructure. And if I'm having to go in IIS to configure it, that's not really what I prefer to do. I'd love to write code and make code work and do TDD and test my code and get it all ready and create pipelines. But the old way of working, where infrastructure was so precious and so hard to configure, was pushing me in writing applications that were maximizing that one or two box setup that I had, versus creating more decomposed applications, because how am I going to get all these other servers from? So fast forward now, we're in the era of serverless computing, and I promise there is no server anymore. Well, there is, but we don't need to manage it that much. And that serverless paradigm is basically promising a new cloud computing execution model, one where the cloud provider allocates a fully managed environment that will scale on demand, right? And as developers, as the creators, we are focusing on writing the business value, the functions, the bespoke core logic, and leaving the rest to the sort of cloud providers to manage. How does that sound?
Yeah, that sounds really cool. And like Tarun said, with serverless computing, we only going to pay for the execution of that logic that we're creating in functions. Now, Tarun, can you maybe show us what a serverless architecture would look like in the modern day?
Sure. So a serverless architecture is moving us from monolithic, iceberg applications to more of packaged, small component-based services. And that's a good paradigm shift because, for as long as we've tried to drive digital transformation, we've found, you get to a point where you can add so many developers, but things don't move any faster. And it's because you're so dependent on that piece of code being packaged in that big monolithic architecture. It's so hard to change things in parallel. And by moving into this microservices or service-oriented architecture or event-driven architecture, we're able to decompose these big pieces into smaller pieces, and therefore we can change them quickly, we can manage them quickly, we can evolve them quickly without having to worry too much about the consequences of the impact to the others. So certainly we're moving away more into the paradigm of event-driven scaling. So if I'm writing small components and it was a Black Friday or a Wet Tuesday, or I was going to run a flash sale, then only these parts of the application are going to scale. And I'm not going to pay for all this other infrastructure that must run for the application to be up.
Yeah, exactly. That's really, really cool. And tell me, Tarun, so a lot of enterprises and companies are probably looking at this because it's in the cloud and it's public cloud in Azure. How, is it possible for us to take these PaaS resources and serverless resources and actually privatize them and bring them into our network, uh, you know, to just basically to keep it all safe from the internet?
That's a great question, Marcel. And I guess the hybrid cloud conversation is real. We're speaking to more and more clients that are telling us that there are parts of applications that will continue to stay on premise for various reasons, and that they're still going to modernize applications and take them to the cloud, but it's going to be hybrid. And so for customers that are running private data centers, you could use Azure Stack and bring the goodness of the serverless to on-premise as well. And the benefit with that is you can manage your cloud environment with the same fabric as Azure manages the infrastructure. And if you're using some of the non-cool cloud providers, I won't name them, by the way, but if you are, right, and you use Azure Arc, you could still manage them fairly well, right, with the same execution model as you would if you were using Azure.
Yeah, that's pretty cool. And yeah, Arc, I'm a big fan of Arc, and there's been lots of advances in Arc as well, Azure Arc. And yeah, it's really, really nice to be able to make use of these tools in more of a multi-cloud rather than just a single cloud. So that's really cool. So we've got a demo today. Darren, do you want to maybe show us a visual diagram of what we're going to show?
Yeah, absolutely. But the one thing I would say, though, the big paradigm shift with serverless also is this change in mindset of how we're paying for infrastructure. We're not paying for infrastructure for having the boxes out there. We're paying for it when we're consuming it. And that pay for use model, the consumption model, I think is a game changer, because now, going from daily billing to hourly to minute to now second, right? So for our clients, if we build our applications with serverless at the heart of it, our consumption bills should not be that high, because honestly, we'll only be paying for the split seconds that our functions are running.
Yeah, exactly.
So the storyline for today is, rather than just bore you with functions, we've sort of taken a typical use case of an enterprise example, which is, hey, we're going to run this new project, and for our business users, we're going to create this really cool website. They'll come to it. There are a whole load of services in it. They'll press buttons and they're going to put data, and that data is going to go into a database, and it's going to be stored there, and there'll be more functions that bring that data back and show it on the website. And I'm sure with that, we've probably summarized 80% of enterprise apps to some scale. And so if you were going to do this in an enterprise with serverless, you don't need to worry about using IaaS, I promise you, because now with static websites, you could bring the functionality of running really pretty enterprise scale apps on a blob store, pretty much in storage. But now storage containers allow you to run a precompiled websites, and you can front them with CDN or Azure Front Door to really get them close to where our customers are. And if you're using Azure Front Door in this case, you could bring them as close as 180 locations around the world. So really, really close to your customers. And then with those static websites, we're going to add some dynamicity by using Azure functions. So to keep it simple, we're going to have two functions, one which does a simple post of the data from the static website, and another function which does a get. Now, in this case, our storage would be on would be using table storage. But again, if you're more on SQL or Cosmos, then you could easily replace this with Cosmos or SQL. In the back plane, though, we're going to be using App Insights, which is really important because you want to have observability all built in from the outset. We're going to be using GitHub for CI/CD. And if we're creating anything enterprise or non-enterprise as well, we want to make sure we're performance testing it from the outset. So we're going to be using JMeter to write some performance tests and then use the Azure load test service to really take it for a test drive.
Yeah.
So that's the plan.
Sounds good. Where do we start? Like, how can we get started with this?
Okay, so let me try and share my screen. We did pray to the demo god, so let's see if this works. So yeah, the good old workflow would have been for us to go into Visual Studio Enterprise or Visual Studio Professional back in the day, file, new MVC, select a template, and we would get this template, right? And that would be the starting point. But what Visual Studio Code has done is it's brought this open source into the doorstep of the enterprise with static site generation engines like Gatsby or Hugo or Vue available embedded into Visual Studio Code. So in this case now, I have searched for Gatsby themes, which if I scroll have some amazing, very pretty, ready to go themes of good websites that have single page or multi-page functionality all built out with nice CSS and templates and themes all in there. So what I've done is basically I've taken one of these pre-templates and cloned this Git repo on my local machine here. So if I move over to Visual Studio Code here, you can see I've downloaded this repo, I've cloned it, it's on my environment now. Now Visual Studio Code is really cool, and what's really cooler about it is if you go into the extension library, the extension library now has a lot of nice extensions that make using Azure easy. So if I go into the Azure Static Web App extension, this is now allowing me to build, publish static websites right from within Visual Studio Code. This isn't a right-click deploy, and next time we have to do it manually. This is right-click deploy, but it in the background creates CI/CD pipeline. So next time you want to run this with a colleague, it's taking it through that pipeline and governance that you've set it up for. So after I've installed the extension, I get access to Azure here, and I can see all the Azure subscriptions that I have. I've got really this nice sponsorship experience from Microsoft for one of the Azure subscriptions. So I'm going to want to deploy my website in there. I can press plus and say, I'm deploying a static website. Select a subscription. Let's try that again. OK, so I select a subscription, and then it says, OK, what do you want to name it? I'm going to select the default. OK. Reload window. We did talk about praying to the demo god, so let's give it another try. So while this is spinning the wheels, we're going to give it 30 more seconds.
Yeah. Sure. See if that comes up.
OK, so let's try again. Let's create a static web app. Still spinning the wheels. OK, so let's select the subscription here, and well, basically, what I'll provide the voiceover while this is spinning in the background is we can take the static website code that we have locally on our machine, and we can work through this wizard, which basically guides us to enter, what the target static website name should be, where's the source code, what static site engine do I want to use? And as I said, right, the library is growing massively. You've got Gatsby, you've got Vue, Hue, Angular. All of them are available out of the box now, so you don't need to create hand crank your CI/CD scripts from there. I could just select the Gatsby engine, and basically it takes the Gatsby engine CI/CD pipeline definition, and it basically publishes it by creating the pipeline for me. Having some difficulty with the environment here. So do you want to share your screen and we'll work through it from there?
Yeah, sure. So let me share my screen here. Let's come out of the presentation here real quick. So as Tarun was saying, it's really powerful to be able to deploy static websites so quickly using templates in Gatsby. So actually the site that Tarun just deployed, we've built a bit earlier, and this is a lander page here. Do you want to talk about it a little bit?
So this static website that I deployed from Visual Studio Code basically has reactive responsive all built in with nice CSS. I could click the buttons, and it's a static page. It's a single page website, which is easily navigating. But what's missing is the buttons don't have any action against them, right? It's still very static, and we promised that static websites can be made dynamic. So what we're going to do next is plug in Azure functions to add some functionality to it. So the plan here would be to build some functionality against the Get Started button.
Exactly.
And why are we doing that?
Yeah. So what we're going to show is the building the function and then publishing functions. Sorry, the function app, publishing functions. And then what we're doing here is, say we've got a new product here on our website under the Get Started button. We're just going to add a simple counter to that because we want to see how many of our people, clients and stuff is going to go, and access this button. So we want to kind of see how many clicks this button gets. So at the moment, you'll see there's actually nothing happening when I'm clicking on that button. So what I'll do is, first off, I'll start off by going into the Azure portal here, and you'll see there's the demo lander static app that Tarun deployed. There are some things here that I've pre-deployed just to save time. We've got a log analytics workspace and application insights that we're going to use to plug into that function app, and as well the storage account that we're just going to use the table storage for our counter, and as well. When you build a function app, you need a storage account, but you can build the storage account as part of the function. But I just want to quickly tell you about the application insight. So just as Tarun was saying earlier, back in the day with IIS, you used to be able to do IIS logs and you have to enable logging and stuff like that. But now with application insights, we can get all of those rich logs and analytics basically straight into this component and to give us nice graphs. And
so your server-side logs, your client-side logs, without having to manually hunt for them, asking your ops to ship them to you and put them on shared locations.
And you get rich metrics and loads of good stuff from that. So let's start first by creating our function. So I'm just going to go into the portal here and go create function app. And we'll search for that and we'll create the function app. I'm just going to give my function app a name. I'm just going to call it counter demo func 2022. You can use Docker containers. We're just going to use a code stack. Now you could use anything here. You could use .NET, you can do Node, Python, Java. You can even use PowerShell core or a custom handler. In our case, we're going to use .NET 6. You can actually go .NET 3.1, but we'll just use the latest here. I'm just going to stick that in UK South. You can pick your operating system. I'll come back to the plans, but you can see here you can switch between premium, app service, and consumption serverless. Hosting, this is where we select that storage account. You can create the storage account as part of this deployment in the portal here, but we're just going to use that one. Consumption plan, we don't get advanced networking. I will come back to this, explain this a bit more. And here is where we plug in that application insights in the monitoring. So we're just going to use the one I set up earlier. And we'll have to tag as well. We're not going to tag for this demo. And we're going to create that. Now, while that's creating, I'm just going to quickly go explain what the difference is between consumption plan and premium plan, or just some of the differences. And it's kind of self-explanatory, really. If you want the premium, you get premium features. And consumption is consumption-based. So you don't really pay for you only pay for the time that function is going to execute your code. So it's per second billing. Now, some of the features that you get, so for example, if you use consumption, you get, you can't really spec the compute underneath the function, the size of the compute. You also can't really run long-running functions. So if you have a function that's going to run more than 5 minutes, that might time out. It might not be sufficient. Or if you want some advanced networking features like what we talked about earlier, like, for example, internalizing your function like VNet integration or private endpoints, giving that a private IP, those are kind of things that you would go for the premium.
So is it, Marcel, fair to say that if I was a dev wanting to prove a hypothesis, I could start by using the consumption plan, because I don't want to really commit to it yet. But when we get to a mature state where I want to now invest in the idea, I could change it from a consumption plan to a premium plan.
Yeah, exactly. You can always change the plan if you need to. And I mean, if you need advanced networking features, it's just the endpoint that is public. So you still have things like CORS, cross-origin, and access policies that you can kind of restrict what can connect to your function. But just to show you what's been created here, we've got our function app and the consumption plan that's running the compute that this app is going to run on. If we look at this function, we don't actually have any functions at the moment. It's kind of just like a container or
just a shell.
Just a shell, really, using that Windows .NET x86 stack underneath, but we still don't have any functions. Now, we could go and create a function in here in the portal manually. I won't be doing that in the portal here right now because
that would have been like going into IIS and manually configuring your website.
Yeah, exactly. So what we're going to do instead is I've got a code repo here, which is actually the same code repo that Tarun used to deploy the Gatsby app, the static app. Now you'll see that the repo root has got the Gatsby app, but we also have a little folder on here called API. Now under the API subfolder here, we can see there's two functions. There's that post function and the get function. So what I'm actually going to do, if I just jump back to the Azure function app, I'm just going to go to Deployment Center. And what I'm going to do is I'm going to link up this function app with that code repo. So for my source, I will select GitHub.
But if you were in Bitbucket or a different repo, then it supports various providers as well.
Yeah, Azure DevOps as well, Azure repos. But I mean, our code repos on GitHub here. So when you do this for the first time, it's going to ask you to sign in and authenticate to that service. But we'll pick the org and we'll pick the repository. In our case, that's going to be build function demo. Select the branch, and you'll see here that the runtime stack is .NET version 6 because our function app is that stack. Now, what happens when I press the save button in the background? Azure is pretty clever. What it's going to do is it's going to create a GitHub Actions workflow or a pipeline, if you're familiar with Azure DevOps. And it's also going to create a secret. Now, that secret is actually the contents of this published profile. So if I just quickly jump back into the GitHub project here, I'm going to just quickly go refresh that. Let me just quickly jump back to the root of the folder. So you'll see in the workflows here that it's actually created a workflow. Let me just quickly jump back to the root. Now, I want to show you a cool feature, and you get this with the free GitHub version as well. But if you press dot on the repo root, it's going to actually open up a instance of VS Code inside of the browser. So you don't actually need an IDE or a machine or something just to get into the code.
And this is different. Oh. Wow. Wow.
Okay.
It's still going? Okay, well, you've had a blue screen there, right? Okay, so what's interesting though is with when he pressed dot, it wasn't that he went into code spaces, because code spaces is different. He basically just opened his GitHub repo in the web IDE. And what's cool now is a lot of the extensions that we're using today with Visual Studio Code are now supported in the web version of VS Code as well. So yeah, if you wanted to use LiveShare, for example, right from the browser, you can do that. Previously, that wasn't available. So plenty of cool functionality there.
My machine's just restarting. Sorry about that. We'll get back to that in a moment.
Yeah, and while you're doing that, Marcel, you provisioned your Azure Function Shell right from Azure Portal.
Yes.
When you scale up, will you still provision it from the Azure Portal, or would you do it differently?
Yeah, so the reason we showed you that in the Azure Portal was because it's very visual when you're first starting out with functions. But once you get more comfortable with functions and kind of want to start, get more comfortable, you can start like automating the actual deployment of the function app, because it is kind of like the infrastructure. So you could use stuff like Terraform or Azure CLI, and just basically automate the building of that function.
Or you could use Pulumi, but you seem a bit more biased towards Terraform.
Yeah, I like Terraform. I would probably use Terraform. So yeah, there's various ways that you can actually create that PaaS service and then kind of link that up with a development team Git repo. Sorry, yeah.
Yeah, that's a great question. So the question was, I've got my serverless set up here, and when I get to a key event in my application's lifecycle, the scaling needs won't just be 20%, 30%, 40% of the workload. They'll be power packed with maybe an amplified 5-factor or 10-factor traffic, right? And the reason what we're talking about later in the demo of load testing is to basically test your application to a preemptive scale of a big event. Now, in this case, using Azure load test, we're using JMeter on a 20 instance VM with 20 concurrent threads across 50 machines. Now, when you do the multiplier, right, that's giving you, almost 100,000 calls per minute. And if you're building microservices, if your QPS is like 2,000 for a key event like that, it may be 5,000, right? But you can almost baseline test it and then devise your scaling strategy aligned to that, so you're not caught out by surprise. That's how we would approach it. I think what the wrong expectation would be to just expect that the platform on the day would suddenly scale to the factor. I think as a developer, we need to put in a bit more work in doing the performance testing upfront as well to know what that scale would be. That's it. Great stuff. Any other questions before we move on? Any questions, Pete, from our online audience?
There's a couple on ASP.NET and the crossover that we've got there. In fact, David Starks asked if there's anything on the horizon for function binding like we see with ASP.NET, so that we can bind models and things like that on the way into HTTP.
Okay, that's a great question. So the question around binding, yeah, I mean there is some work underway on the product roadmap to bring some parity. More specifically on the binding, I wouldn't be able to confirm the timelines on when that's due to be released, but I've certainly seen that on the backlog.
Yeah, sounds good. And Boris Lang has also asked whether or not there's likely to be any support for ASP.NET Core in Azure Functions.
Core, well, I would be surprised if there wouldn't be support for core. I mean, the direction of travel clearly seems to be core all the way, right? So it's probably just a matter of time.
Questions. Chris Dexter asks, can we overuse Azure Functions, splitting up our architecture too much, or is going all in one Azure Functions a thing?
Yeah, Purnima, that's a great question. So I guess the question there is saying how much is too much, right? How much do you decompose before the decomposition is too hard to manage? And we see that a lot, and didn't we see that with solid principles where you could go down the route of open close and find you've open closed it so much now that when you refactor code, it's so difficult because you've made it too granular. And I guess you have to find your own balance with this stuff. I wouldn't see a customer going from monolith to fully microservice right away. There has to be a pivot point where you gradually break down your components. So functions support granularity to a great extent. You could have linked functions where functions are calling functions, and those linked functions can talk using service bus messages as well. But see, the one thing you need to bear in mind is if you're making 2 or 3 hops between functions and you get into error states, now it's too difficult to correlate the failures. And maybe that's the boundary of where you say further decomposition is not going to add any more value.
Sure. Chris Lloyd Jones, he builds upon this question asking, if we have Azure Functions and Serverless, where do you see Dapper and Azure Container Apps fitting in this picture?
So I did tell my friend Chris Lloyd Jones to only ask easy questions, but clearly he decided not to. Yeah, I guess we always have this great option with Azure where we go in and we see there's 10 separate services to do one thing, right? And our customers get that all the time. I could use Azure Functions, and now I can use container apps, and I could use a full-blown Kubernetes cluster. I could still spin up a VM and run IaaS if I wanted to. So the options are out there. I don't think there's going to be a natural conversion where one tool fits across all use cases, cutting across. That won't happen. So Chris, I think the frameworks of Dapper and Kada will prominently find the best place for themselves in the container space, especially around Azure Container Apps or Kubernetes. But I also see if you're using Azure functions with Docker, with container hosting, then there could be some parallels to use those frameworks in there. But I guess if I was purely going down the serverless path with Azure Functions without containers, then I wouldn't see a segue for it. Great. He's giving me a thumbs up, so I guess I've answered the hard question.
Hey, I'm in back in Teams now again, but I just need to get the meeting organized. Permissions to present.
Okay. Can he get the organizer permissions to share his screen again, please. So while we're doing that and filling the gap with questions, any other questions we can fill the gap with? Go on, Chris. Whoa, that's a great question, Chris. So Chris is asking, I've worked in ways where I could just attach a debugger from my dev machine to a server and debug the code. Are my security architects going to be happy if I told them I'm doing that with the cloud? The answer is no, because you would probably want to move into a paradigm of observability first. Therefore, rely more on embedding metrics into your log analytics with App Insights to be able to capture when things go wrong. So you've got good telemetry and a good audit of where the failure happened. I guess it is still okay and practically supported to go in, install an extension, and being able to remotely debug a function per se. Whether it's recommended, I don't think so. I think you should move left and say, how do I improve my telemetry on the application to get what I need so I can find the issue faster rather than debug it remotely. Great stuff.
Okay. I still having some problems here. I'm
Okay.
afraid.
So, right. So, is it possible for him to get presenter permissions? Yeah. Okay. So, any other questions we can answer in the meanwhile? Yeah. Yeah. So great question again. The question is, the other cloud provider that's not very popular has some principles. do we have? No, I'm only winding you down. So the other cloud provider has some great principles around designing and architecting applications for cloud native. Does Microsoft Azure, the superior cloud provider, have the same principles? And the answer is yes. The five pillars of well-architected framework are consistently there for GCP, for AWS, for Azure as well. There's actually a whole page on Microsoft Docs which talks about, how do you design your applications to those five pillars? And when you're talking about five pillars, you're talking about total cost of ownership, because we just can't say provisioning in serverless is cheap if you need to build an army of ops people to support it, right? So you need to look at the total cost of ownership, and then you need to look at the economics of how do I apply FinOps to manage my workloads, therefore not spending too much on consumption and finding that right balance and being able to taper things down when they're not being consumed. But equally, how do I recover from failure and disaster recovery? So yes, there is a lot of guidance and on the documentation page which covers that.
Awesome. Yeah, unfortunately, I can't
Okay.
share my screen. I'm not sure exactly
Okay,
why.
so let's do this. Why don't I flip back into the demo here? Hopefully my screen's showing up now. So let's go back into the demo that we have here in the resource group. And in this resource group, as you can see, we have got the Azure Function app, which you provision.
Yeah.
And within this Azure Function app, if I go in, we have two functions now created, because you did trigger them before it got taken out. So
No, I basically need to update the GitHub
okay.
repo. So
okay, so we'll do some voiceover, right?
Yeah.
So here's your get function and here's your post function, and these are the two functions that are there.
Yeah.
And the get function is basically just going in and getting a counter from the storage. The post function is updating the counter.
Exactly.
And did you want to plug that into the Gatsby website?
Yeah. So I can actually, if I can go into this resource group here. So I'll just quickly show you. So the two functions that were created was the post and the get. This is then linked with GitHub. But if we jump back just quickly to the root of the resource group, there's a different Gatsby app there that's already got the counter plugged in. So if you want to show the GitHub repo, maybe we can show the code a little bit of the.
Yeah. Okay, let's see this. So I have that one open here. This is the one, yeah?
In the other resource group, sorry, not.
Okay, in this other resource group. So this resource group?
Yeah.
Okay. Oops. So we have
a different app in there.
is this one, counter
This one there.
the builds one. Let's go in there and let's open this.
Yeah. So okay, yeah. So basically, if you can quickly go to the GitHub for us, the GitHub page, just with the code, the GitHub repo, we can just quickly show, yeah, that one. And so in here, you've got the two APIs, and the post API will basically, what it will do is it will connect to a storage account, and that storage account, it will look for a table called view counter table. And if that table doesn't exist, it will basically create the table. And if the table does exist, it will look at a key. So the post request is basically going to be sent from our Gatsby app. That's going to post, and it's going to create a row key with a counter. And every time that button is going to be pressed, it's going to increment the counter by 1 so that we can visually see that. So on the Gatsby app, if you just want to maybe show the code of the source page.
Okay, so sure, good idea. So just going back to the code here, now that we've got the function, we've built it out, there's a bit of code in the Gatsby app where I need to plug that function in. And so I'm going to navigate into the pages section within my static app. And this is a single page application. So I'm going to go into the single page. And you can see here on the screen, well, basically what I'm doing is I'm returning some HTML. And to add the dynamicity, I'm taking the button click event, and I've got an event handler for that. Now this is just React, right? So if I go into the event handler, what I'm basically doing is I'm saying this is the function URL, and I'm using Axios here, but you could do this natively in React as well if you wanted to. Pass the function URL in the body, pass the key, a value, and then call the Azure function, capture the response, and then publish that response on the UI. So we're basically seeded here a call of post and a call of get for our Azure functions. And then we've basically returned that into the HTML, and then we're returning the whole HTML on the page. So, it's fairly easy then to start plugging into the different parts of the static website, whatever functionality is needed. And if really I wanted to distribute this further, I could have the Azure function flow where it writes a message in a service bus, which is then read by something else, and it does a reactive response to it, or plug in Logic App to go and feed this now into a CRM system or whatever, or plug this into a tweet or something, right? So the use cases are really limitless in that case. So with that now plugged in, if we come back to the website and we refresh this, let's press F12. This is where we have the Get Started button. So if I press this, I can see the number is showing as 53.
Yep.
And if I refresh this again, and if I press it again, it shows 54. So both the events are being triggered. When I click the button, it's going off, calling the function to make an entry in the table. And then brings the result back and shows it here. And to make it work, we had to make one change, didn't we? We had to update cores.
Yes, exactly. So in the function, we would have, for this to work, we would have created a connection string in that environment variable to be able to connect to the storage account to be able to update this table. But then also for this, because the static app is a separate kind of site that is trying to post to our function, we have to actually allow the cores on the function app to basically talk to this function app. So we had to add that in as well under the cores allow list.
So cores, this is by design, right?
Yeah.
So cores is by design, right? This is really there to make sure you don't have cross-domain origin requests going from one place to the other without you whitelisting it. And that's, you're using consumption plan here, and it's allows access externally. So you want to make sure you're only allowing access from domains you trust. So that's an entry you make within the Azure portal to allow for it.
Yeah.
So with that done now, we want to go back into the portal. And Marcel, you'd created a load test, hadn't you?
Yeah, so it's just at the bottom there.
Yeah.
So this is a new service in Azure called Azure Load Test. And load test is really, really cool. So you could basically set up new tests. If you want to jump into the load test there.
Yeah, just Is it this one?
Yeah, that's the
Okay,
one.
let's go into it.
So it's still in preview, but just wanted to show you. So if you go to test, you can either create a test which is you could just kind of hit a URL with a load, or you could use JMeter. Now, so JMeter test is basically, what is JMeter? It's basically an open source framework that you can write quite some comprehensive tests for APIs or endpoints, and then what we can do is we can upload this JMeter into this Azure load test, and then we can actually scale how many instances. So if you just want to go there to if you go back, sorry, one, and go to edit, just want to quickly show that. So yeah, go to the load test. So you could basically scale the instances, how many instances you want this load test to run. So if you go to configure and then test, you'll see here, this is where you'll basically set up the name, the test plan, where you can upload that JMeter test. And this where the cool stuff comes in, where you can actually
Pack the power
in.
Run the 50 engine test with multiple threads to
Yeah.
really hammer it, right?
Yeah.
And you want to be testing for that. Now, again, as a developer, I don't need to set up a machine, a load test rig, right? I'm relying on the platform to provide that capability. So that's a big plus.
Yeah, that's, and what happens here is we're adding the under monitoring, we can add all the components in that makes up our function app. So we can add the storage account, we can add the app service plan. And what's going to happen is it's going to take all the metrics from that load test, and it's going to correlate them together into visual and representation of how the app is performing, you know, how the infrastructure is performing. Yeah. It's really amazing.
You get all the metrics in one place. And so as a developer, because we're using cloud native components here, it's able to take the metrics from Azure Function, as it's able to take the metrics from storage, from front door, and correlate that on a single pane of glass. So we don't need to go and scavenge for them ourselves.
Yeah, exactly.
And then what's cool is, as you were going to say about the comparison as well, right? You can compare two separate runs to see whether the performance is improving or degrading.
Yeah. And you can add extra metrics. So it comes with some metrics when you add each component that makes up the function, but you can add additional metrics. So say, for example, you want a total connection count into the function, things like that. So it's loads of things that you can put in extra there and get some really rich data. And then Tarun will also show you now how you can also use application insights.
Yeah, and we're using App Insights in our static website, and we can capture a lot of metrics from it. But again, the beauty of it correlating all the metrics, showing you on a timeline where things are failing, but also it's giving you that click-through functionality. So not only can you see the error when the exception happened, but oh boy, when you click on the exception, it even gives you a stack trace. And you could take this a step further, integrate that with your GitHub issue or Azure DevOps, and get your engineers to start working on these tickets, resolving them, deploying through the pipeline. So that goodness cycle we were talking about is all built out into the platform. So again, as a developer, right, I don't need to worry about it. It's all provided for. So with that, Marcel, we have talked about many things. We have talked about serverless. We've talked about Azure Functions. We've talked about running static websites, and how do you add dynamicity by using Azure Functions in static websites, using storage. And really, the drive here is to move you from this paradigm of monolithic applications to more event-driven, responsive, reactive, scalable applications, to go from big icebergs to small packages of composable applications.
Yeah, and it's really, really good. Like Tarun said, you can really break down, and have reusable bits of code in the form of functions that can just get triggered, and you just pay for when they run, really. So no service to look after, no service to patch or anything like that. And especially with the load test feature now as well, in Azure, we could write our JMeter tests and just hammer our APIs and load test them and get some rich analytics out of that. Yeah,
great stuff. So
awesome.
To our lovely moderators, are there any other questions?
Yep, we have one more question from Elliot. She asks, does it have any DDoS protection?
So great question. So if you're using static websites already, it has DDoS plugged in. There's also a new offering in static websites where you can use the premium plan rather than the free plan.
Yeah.
And the moment you enable that, you now have Azure Front Door in front of it. And as we know, Azure Front Door provides you OWASP top 10 vulnerability protection. So right from DDoS to SQL injection, but it also brings your data to more than 50 CDNs and 180 locations. So it's closer to your customers. So
Yeah.
absolutely, to answer that question, yes. You get DDoS even in the free version, but you get top 10 vulnerability free with Azure Front Door when you upgrade to the premium plan.
And also with Azure Functions on Premium, you can actually bring those into your network. So they're protected by the network barrier using private endpoint or VNet integration. So they're not even out on the internet.
Sure. We have a question from Narayana. We are asked, we are using Azure Service Bus queues to store customer data messages in their respective queues dynamically. Currently, we are using Azure Web Jobs to process the respective queue messages for the customer. And we have one step in this whole process manual. Every time a new customer adds, we need to update the job to process the respective customer queue data. Does this Azure Functions help in this case to handle dynamically?
So no free consulting, Narayan, there. You have my Twitter handler, right? Let's talk some business. You have a very specific problem. We're happy to take that offline.
Yeah.
But yeah, the answer there is absolutely, right?
Yes.
There's possibility of being able to decompose that part of the workflow and use serverless with Azure Function to handle that workflow.
Yeah.
Didn't you define a janitor function for your client recently, which was basically going in and performing a lot of these repeat tasks that were
Yeah.
done manually
Yeah.
in an automated fashion?
Yeah, sure. Yeah, you can definitely do, there's so many different trigger types, and you can have timer triggers to clear that queue. There's different ways to tackle it, but definitely you can have a janitor, almost like an operations function that will go and often do a little operation. And like I said, you can use maybe PowerShell.
Yeah.
To go and trigger that.
And it's not really functions, it's functions, right? It's a lot of fun, right? You could pack anything into the function and get it to do pretty much anything.
Yeah, exactly.
Great stuff. So our organizers are telling us it's time up. We've only been paid to talk so much, so we'll wind down. But it's been amazing coming back in person, speaking to you lovely people and those online. Thank you for the opportunity. Hope you enjoyed the session.
Yeah.
Don't forget to give us a rating, right? And that'd be 5.5. Yeah. All right. Thanks, everyone.
Thank you. Yeah. Thanks.